This is a demonstration of the MVP build of Pixel Walker. Pixel Walker is a technology demo exploring the field of machine learning. This is Dave, a machine learning agent who has been taught how to activate objects and navigate around the scene. Dave is controlled by submitting typed messages. These messages are interpreted by the natural language processor, GPT-3, through the OpenAI platform, so the user is prompted for the required GPT-3 API key on first load. If a valid key is given, it is saved as an encrypted string in the user's documents folder. Now that we have a working key saved, we can begin using the application. Currently, Dave knows how to answer questions, find objects and locations, and toggle activatable objects. We will ask Dave if he knows if there is a can of paint nearby. Dave has indicated that there is, by sending the message to us in the text box to the right of the screen. Now, let's ask Dave to find a can of red paint. And here it is. Dave also knows the difference between being asked to navigate to an object and being asked to navigate to a location. There are 4 different locations in the scene: a workshop, tool room, paint room, and music room. Let's ask Dave to turn off the drilling machine. He knew we meant a drill press. Dave lets us know that the drill press is already off. Let's tell Dave to turn it on. Several other objects can be turned on and off in the scene. Dave is able to respond to the user's input by first having it processed by GPT-3. This works by surrounding the text with a prompt that gives the processor context in order to predict what text might follow. The ability to design different prompts allows for a wide range of different uses. The prompts used for this application are located in a JSON file that is loaded at runtime. When the user submits input in our application, a prompt designed to classify input is used to determine if the user asked a question, made conversation, or was giving a command. Here is an example of part of our prompt used for sentence classification. The text from the user's input, highlighted in blue, gets added to the end of the prompt. The response GPT-3 is expected to give back would be command, stop. The stop token lets GPT-3 know it doesn't need to keep generating further tokens. If the user's response is a command, another prompt is designed to parse the command into its components: action, object, and location. Dave was taught to navigate through the use of the MLAgents Python package, which is built on top of PyTorch, a popular API for machine learning. Training produces a neural network model to control a decision policy used by the agent at runtime. MLAgents provides both proximal policy optimization and soft actor critic algorithms for training. We generated slightly better results using the soft actor critic algorithm, but this could also be due to the parameter settings we used for training. Training Dave to navigate required several iterations of trying different types of observational data and reward design. 2 sources of observational data Dave uses are raycast sensors and a grid sensor. The group of raycast sensors on his feet give positional data of any surfaces they encounter. This helps Dave make immediate movement decisions so he can more easily avoid collisions with his surroundings. The grid sensor gives collision data of objects inside a grid of cells surrounding the character. This provides Dave with a better understanding of which path he needs to take to find openings between obstacles and doorways. It doesn't help him avoid collisions as well as the raycast sensors, but it does allow him to make better decisions on which way he should turn and travel to reach his destination. That concludes the overview of our MVP build of Pixel Walker. We hope you enjoyed it and have a chance to experiment with our software in the future.